we've had a fantastic day so far. We've seen the overview of the successes of RICAIP. We've also had a chance to glimpse into the future of RICAIP here at SIG, but also at the other partner institutions. And we had a very stimulating panel discussion where we discussed the importance of talent for the success of Industry 4.0, which was very, very encouraging. We have two keynote addresses awaiting us. One, the second one from Professor Duncan McFarlane from University of Cambridge, which we're very much looking forward to. But the first one from a man, the titan of Industry 4.0, who you've heard from already today. The keynote address will be called Smaller, Smarter and Trustier European Strategies for the Next Generation of AI Systems. And that man is Professor Wolfgang Wahlster, the CEA of DFKI Germany. So please join me in a round of applause. And Wolfgang, the floor is yours. Thank you.
Thank you very much for the kind introduction. And actually, you already heard the title. It's about European strategies for the next generation of AI systems. So we look into the future, smaller, smarter, and trustier. I first will discuss the German high-tech agenda. Actually, the road mapping process, the first version was processed only last week. I was there, I was on the committee, I contributed to this agenda, and we will go into this. What does Germany plan for the next years in AI? Then I will talk about the trend to go from generative AI to agentive AI. I will challenge some of the fundamental theses, or hypotheses of the, let's say, success of LLMs, which is of course there. Attention is not always sufficient, this I will show, and bigger is not always better. These are my two challenges. Then I will show that there are concrete projects for sovereignty in open source foundation models, like the SOPHI project. And then at the end, I will talk about digital twins, physics-based simulation, physical inspired AI, and SAMs, so-called small action models for worker assistance. And then I will conclude. First, let me go a little bit into the high-tech agenda. Germany's high-tech agenda, this was a long preparation phase, about 1.5 years, and now it was published. First of all, the aim is really a AI-first strategy, and the aim is to have 10% of our economic output in Germany based on AI by 2030. All the researchers in the room were a bit, shocked, because if you really compute this 10% of the economic output, this is a tremendous amount, and we are not really sure whether we can reach this. But anyway, it's an ambitious, very ambitious goal, and we try our best. First goal. Second goal is that we have measurable improvements of the availability and also usability of AI capacities. This concerns not only algorithms and data, but also the computer software tools and AI chips, of course, for academia, research, industry, and administration, and finally also, of course, to civil society. This is, of course, more general, but you will see that our new government, they insist that for every roadmap, you have to present concrete figures, like the 10%. And I will go a little bit into this, so that the output really can be officially approved or not approved, that you reached the goal or didn't reach the goal. This is something I was used to when I was in the States, working in the States as a researcher. DARPA always tried to set goals which are measurable, which you can really operationally approve or not approve. And then the third goal, overall goal, was that Germany also should be a key player in the next generation of AI in the global competition. The aim is to provide everyone with AI assistance on a broad scale. That's what we heard in the panel discussion earlier. For example, in industry, at home, in nursing, in healthcare. I was, as I said, involved from the beginning, and this was a committee which has the name Platform Learning Systems. It stresses a little bit the success of machine learning, but now we will change it soon. I think the government no longer wants this with the learning systems, but anyway, it's a platform there for AI. Our minister always says now platform for AI, but the official title is still platform learning systems. Now, let's check the content. Here you see Minister Beer and our new Chancellor Merz together, and they go quite often to the press, give talks about this agenda, and they say integrating AI into manufacturing should be a priority also for Czech Republic to maintain their competitive edge in global economy. And the European cooperation on AI standards is extremely important. For instance, for digital twins and twinned AI, standards for advanced machine learning algorithms, standards for edge AI computing, for AI processing of multimodal data, and also, of course, for physical world models. There are some new trends which we will push in this move to the new road mapping process, namely ultra-compact language models. The models which we have now, they are inflated. There is too much in these models, and actually if you do too much, hallucination begins. But I also wrote a paper where I showed that, for instance, in ChatGPT, the main problem is not so much hallucination as ambiguity. You get answers which are extremely ambiguous. You can think this was an answer, but also just the contrary also was contained. So this is impossible. I mean, in science, you are trained to be unambiguous when you say something, and not. We found in ChatGPT answers sometimes you have 10 different readings of the same output. Extreme ambiguity. This is not the hallucination, because the ambiguity is really there. And the user has to find out what is meant. Hybrid neurosymbolic methods, also very important, because for a long time there was a kind of a battle between people who favored symbolic models and the others only neuro. And this is still the case. When you go to a big conference, you have the NIPS conference, you have HKI, you have AAAI. AAAI is more on the symbolic side, and DFKI also. They have, of course, neural papers, but for instance, in NIPS, the symbolic part was banned, more or less. Then also a very important goal is long-term autonomous systems based on multi-agent technology, and I think this is a very fascinating goal. I will go into this later. But before, let me show you the high-tech agenda as it was officially promoted May 21, only 2 weeks ago. This happened, and the result you can read now. It's available on the web, and I have here copied some milestones to see what is already for 2008. We should have more than 100 transfer examples and best practices of projects which are now running and maybe ending in 2028. So this is also quite hard to achieve. Then we want to establish 3 or more European frontier labs. 50% of the small and medium enterprises in Germany's manufacturing industry use AI in their core processes, and again, 2029 is the deadline. Again, boy, this is quite ambitious. And domain-specific AI models for innovative components for security, safety, efficiency, trustworthiness, or interoperability. Again, 3 such domain-specific AI systems in 2029. Startups. 2030, more than 4,000 startups. I mean, we create startups in Berlin at a rate of, let's say, 200 per year. This is quite, but not everybody survives. Yeah. In DFKI, we have right now about 100 who are active. These are companies which exist, which make money and so on, and which go to have a good future, I think. And the last just example I want to present is that AI compute support is quadrupled compared by 2060. I think Antonio Krüger has mentioned this. The infrastructure still is very important, and 2030 already 4 times more spending on the support. Now, I already, when I was introduced this morning, I already mentioned the teaming for excellence in RICAIP. And this is a picture which was generated by some AI system which I used. It's showing, again, DFKI, CEMA, CIRC, CTEC, and the transfer of knowledge with these teaming efforts, namely from Berlin or Saarbrücken, Kaiserslautern, DFKI, to the Czech Republic, where we concentrated on high precision and industrial as an industrial bridge. And I think you were the first at CIRC also to approach some of your hidden champions here in Czech Republic directly and introduce some of your results in the manufacturing processes. And then the new thing is India. You see here always a picture which shows you this is the symbol of India. And this is in at NIMS University in Jaipur in India. So you see the chain, yeah? We started in Germany, we went through Czech Republic, and then now India. And this can go on. I think if you have such a chain, it's wonderful. And all these institutions have very nice building. One here from Saarbrücken, which we own. It's our own building from 1988, with some sponsorship, for instance, from Inter. Then Prague, beautiful, experimental, innovative building here. I think it was established 2013. And now the new one in Jaipur, which also looks very good, and says this is the Magic Institute. Now, from the academic side, we see that we have various trends which overlaps. No of these trends here, starting with the classic symbolic AI, is really dead. So there is still a lot of research to be done, and also the higher level trends refer to the lower level in many cases, because we have hybrid models. But as you know, the classic models were knowledge graphs. They are still used. When you go to Google, for instance, they will tell you that 70% of the work for answer of Google are not by their LLM, but by the knowledge graph. The knowledge graph is one of the biggest assets of Google to make sure that you don't get nonsense as answers. So the knowledge graphs filter out bullshit, so to speak, which was generated by neural networks. On the other hand, you need the neural networks, of course, it's not against them, but you need this intelligence filter. The same is for inference. Terminological, logic-based inference was studied in symbolic AI for a long time, and you have very solid mathematical results. Generative AI, this is now mainstream. Everybody knows it and uses it. This is the deep learning with transformer architectures. By the way, many of these things were invented in Europe, and some even in Germany. The term transformer, like industry, was coined in Germany and was a German scientist. He worked for Google, but he lived in Berlin. And so this is one of the most quoted paper which was generated in computer science. I think they have over 1 million quotations. 1 million quotations. Only the Bible is quoted more often. It's kind of the Bible of technology, and Transformer was the name, or is the name. Then the newer trend recently, the last 5 years, people said, generative AI is quite good, but we need more. And this is the combination of neural and symbolic methods, very successful. And many people do it. Some people don't want to mention it, because there was a saying that symbolic AI is the good old-fashioned AI, which is nonsense. Mathematics, I mean, you cannot say this is old technology. And agentic AI is the most recent one, which, as I said, wants to aim at long-term autonomous execution of tasks on behalf of human users, and they use many small language models, as I will show in a minute. So let's start with a deeper analysis. Generative AI, as we know, does predictions. It generates something, and many of these generative AI systems are linked to ChatGPT. So this is text data is the input, the output is next word, so a string of word and whole documents can be generated. Image data also, then pixels are predicted, or video data, then the next frame of a video sequence is predicted. All this is done mainly in the US and China, not so much in Europe, but we have one domain which is very important for Europe, and we have a lot of such input data. This is business process data, especially models. And as you know, SAP is the worldwide leader in process models, and they have models, and this makes some politicians in the US a little bit nervous. They have all the models of the big companies in US. For instance, Bank of America, Wells Fargo, Ucratica, all this knowledge has SAP, not the US government, and not Google, and not Amazon, and so on. So this is the asset we have, and we should concentrate on these process models for industry and business. We have introduced the term LXM. X is a variable, like always in mathematics, a small letter for a variable, and this variable can be used for X equals L, which is LLM, or X equals P, which means process, large process model, or, very important, X, the X is an A. This is then a action model. We always say this is a big mistake of generative AI, that nothing happens. It produces a text, it produces a nice picture, video, and so on, but what is the consequence? No action. We say sometimes it's a little bit like NATO. NATO means no action, talking only. And this is ChatGPT. It talks a lot, but it doesn't do anything. And this we stop now. In SAP, there is a very large department headed by Dr. Herzig, and Professor Hutter also helped a lot. We worked also on this. This is a new relational model from SAP on training with business data. And it's Rapid 1, very successful. And when I proposed this to our government, even our minister, she liked it. And she gave us a amount of money. We just got on the May 1st letter that now the project is started. And we got, for the basic research we have to do here, 4 million euro, which is not bad. The only problem is that the projects have to be faster and faster and faster, and research with high speed. So it's only two or 3 years. So you see it comes to an end already at October 31, 2028. And we will see. And you see it's DFKI is the main contractor. Expect is a small and medium enterprise. Actually, it's also a spin-off of DFKI. Then Shea is one of the largest company for process models, very successful company. And SAP Signavio is a subsidiary of SAP. They don't need any funding, but they are associate partner. They give us the code and so on. We work together with them, but without funding. And it's funded by the Federal Ministry of Research and Technology. So I hope you will hear a lot at next conferences about the results. Now, just when we go from talking with chatbots to acting with robots, we start again also with machine learning, deep learning, of course. Learning by demonstration is often used. New wave, we work at DFKI a lot, for instance, in Darmstadt, on reinforcement learning for robots. Continual learning is very important in some of our applications because, for instance, in automatic driving, autonomous cars and so on, you need the continual learning. During driving, you learn a lot. Large language models, we all know, large action models have to be combined with multi-agent, because in the end, without the agent model, the large action model can tell you what to do, but somebody has to do it. Either you do it symbolically with the action models, you do it with agents, or you use robots. Both options are there. And then we need, of course, multi-agent platforms. And here, Professor Magic has done a lot of work. Also at DFKI, we did this for a long period. We have also published books, everything, habilitation thesis, and so on. So we have quite an experience which we can use for this. As I said, for LPM training, we need process data, best practices, we need standards and guidelines, and again, this is the strength of German science. Some people say too much regulation and so on, but this is not a regulation. It's proposing a standard, a concrete standard, and we actually aim at standards, and we have some, which are machine not only readable, but understandable. So our vision is, and we have 3 examples where it already works, that the machine, when you buy a machine, and you saw it should be compliant to ISO norm, a special norm, then you can download this norm, and when you kick off the machine, it will automatically say, no, it's not compliant to this. Yeah, this is, and Dean has done it. My advice, it was my advice, I was a mentor of this project, and I'm really proud this is starting to work. Of course, Dean has so many standards, it will take a long time, and also we need special sensors sometimes to really check for the compliance. But anyway, then the alarm training is also possible. We have a lot of human action logs. This is, I think, here in Czechia, in Prague, the same problem that our working unions also want this, and this is good. It's a good side effect because they look very carefully what is going on for the individual worker. They have protocols and so on. In the US, for instance, and this is a little bit sloppy. In China, it's not done. There is no way to do this. So I think that in the end, the trade unions also have a kind of positive academic input. Yeah, and then, as I said, we need not only the LLMs, the LPMs, the LRMs, but we need also the knowledge graph. Constraint solving is a very strong technology and very with a high TRL level. Again, I can quote Google. Google has a center for constraint solving, believe it or not. You would expect for LLMs, but no. For constraint solving in Paris. Yeah? Physics-based simulation, that's the next big thing, I think. And then deductive and abductive inference. This I skip. Now, let me come to the problem of big models versus small models. Here I have this analogy from history. David versus Goliath. I think you know the story. Yeah, where there is a lesson from a small boy who defeats the giant, but not with human power and special weapons, but with brain. He developed an intelligent solution, and this was the basis of the success. And in general, we have now some small language models. that are generally, of course, faster. They cost less, they consume much less power, and they are easier to manage than LLMs. Because they focus on a single domain, the small language models are less prone to hallucinations, and as I said before, they generate not the ambiguous responses as much as they do the large models. So incorrect outputs, which are essentially made up, are not so much an experience when you use the small language models. So this is good. And it also became clear when we started to work on this that in many fields, especially in manufacturing, if you deal with a special machine, let's say laser cutter, or you want to have a system, Siemens, so-called gas turbine. You construct a new gas turbine. Why should you use a large language model which tells you what was a famous story by Goethe or a poem by Brecht and so on? It doesn't matter. It's not relevant. And you know from learning theory, the more you know, the more confusion is possible. And therefore, we concentrate on smaller models. And there is a very interesting example. They call it ultra-compact AI systems. Maybe you have read about it. Tiny recursive model. You can even download it. And this has only less than 0.11% of the parameters. And in the general intelligence benchmarks, it's even better than the very large language models. So it shows that sometimes smaller is better. Smaller is better. And this was a big shock for some of the big companies which invested a lot, but I think it lasts certain time and digestion of the venture capital people. If you tell this Elon Musk, he would be shocked, I guess, but I think he doesn't understand it. And anyway, he goes, straight, go on, invest in extremely large models. And what I'm saying is not that we should stop to use them as long as it helps, for some, but we should be aware that especially in manufacturing, I think large language models actually don't make sense, except for the user interface to manuals, repair, and so on. To have a language model in the background can be very helpful for search. Now, let's assume we have a cooperation between companies. We have, of course, a lot of big companies in China, in US, outside of Germany, and they have a factory, and for this factory, for instance, they have a large action model agent. So this large action model can interface with a lot of smaller companies. Germany is famous, like here Czechia, for small, very specialized manufacturing companies. We have manufacturing companies who know how to wrap toilet paper. They have only one product, but this is a world-class product, and everybody wants to have these machines. They have also for pasta packing and so on, all very specialized. And of course, the alarm agent, if you have a bigger factory which use such components as subcomponents, so they communicate with the small agent models. So in Germany, for this small company, we have a small action model, but this small action model can be driven or guided by a large one. The LLMs, as I said, you can go on with that because sometimes you have human involvement, and then the LLM is very good because it's also natural language based and so on. People understand this. And the large process model is very important for large factories, of course. Then you can have the control. So when you combine all this, it's a nice picture, so that in Germany we have, for instance, a division for planning and controlling the process and the product. This is a company which is based then in Germany, a smaller company. Then we have a couple of factories which all together deliver components for the large manufacturing company, and this is already the case right now. When you go, for instance, in semiconductor industry, in Germany we have a lot of companies which are providers for TSMC. TSMC, as you all know, is the largest semiconductor provider in Taiwan, worldwide #1, but they use a lot of components which were actually done in Germany. They are also produced only in Germany. They are shipped to Taiwan and then they are used for the chip production there. Yeah, but you can do more with this type of architecture, where we have, for instance, not only the alarm agent, but we have a compliance agent, we have a safety agent, as I said, and we have not only normal evaluation of neural networks, but we have abductive, deductive, and inductive inference. We have the constraint solving, the knowledge graph, and continual learning. These are all used in process planning together with the alarm and the large process models. And also in process execution, it's very interesting to see that the machine learning for edge computing gets more and more realistic. We do it more and more, that really at the edge of the production machine, we do some retrofitting sometimes. We attach a simple cyber-physical system, very cheap, to the old machine, do a retrofitting, and then we can even use edge computing for machine learning directly on the machine. And of course, physics-based simulation. Let me show you a concrete example of the process models. So there is pre-training for structured data. They are powered by business data, as I said. It's in-context learning. The context is extremely useful, and they use large contexts here. It's possible now. And they are resilient to changes and incomplete data to deliver really dependable predictions. There are two commercial versions, a small one, a larger one. And here's a simple example. This is from a business process, namely payment delay prediction. So before you do your monthly planning, liquidity planning, you go and try to find out, does this customer pay in the right at the right deadline? And then you see these things here. The system says, it's not in the database. Yeah, you see it's tabular data. It's not like in ChatGPT strings. Yeah, and just word sequences. But here this is in a relation. So you have a tabular data here. And okay, it says predict. Now you want to get the prediction, and this is actually done. So the system fills in. Of course, it depends again on the training and the learning, but this is accepted by companies right now. You also can do this for sales order completion. For instance, you have a sales order, but it's incomplete. Again, you see predict, then you push the button, please predict, and you get results in a few seconds. So this is a very popular application, already used by many companies, but there are more. For instance, in production, delivery delay prediction, damage code proposal. Often in assembly, you know this also at SEMA, you get a lot of stuff which is already rubbish. You cannot use it. It was in the logistics, some damage happened to this component, you ship it back. So and then there is a damage code. You say, what kind of damage was there? Is it a severe damage, unusable part? Is very problematic. Return order auto-completion. You return an order because you cannot fulfill it, then auto-completion, again, you don't have to write it. Or the failure mode is identified. The business aspects like payment anomaly, project cost forecasting, tax code prediction, also very important now with the tax, that you have to route these objects so that you minimize the tax, especially with Trump. You have to every week to retrain this. But anyway, this works quite well. Now, as I said, transformer, was introduced in a paper which had the name "Attention is all you need." I think everybody knows it here. Attention is what you need, but you need more. It turns out that this is not enough. Only attention. You need also causal and teleological reasoning. Why does somebody do something? This is not causal. Causal is physical, but teleological is what is the intention. Continuous learning, I already mentioned, adaptive conscious perception for robots, and very important, understanding the physical environment. And so what I'm saying here is that the future AI architecture is expected to embed transformers, but with broader systems. So we have new hierarchical, neurosymbolic learning methods. That's one topic we are working on at DFKI. Innovative sensomotoric components for the robots, extremely important. And elements of emotional and social intelligence, because when you interact with humans, of course, this is an extremely important aspect, and it's only the research only started. So I have to come to a conclusion soon. I just wanted to mention Sophie. You can look it up. This is a sovereign open source foundation model implemented completely in Germany. In Europe. Germany was heading the project, but it was a big consortium. Very interesting. It's already running, and the results are encouraging. In many cases, the system has, in the benchmarks, better results than some of the other models from US or China. And as I said, the future is the use of softbots, cobots, together with the worker. We tried this very early, but this I wanted to show you because it's a nice, very nice demonstration where the management of Volkswagen was really extremely pleased to see this, and they sent us a letter to say, as a testimonial, this is such a breakthrough from their point of view. Why? Because it, as I said, it combines physical knowledge, knowledge which was learned by observation, data from assembly, and the nice thing is that it also can give you a full explanation why the worker should do this and that. This is the explanation facility and what we call also trust into the system, because when you understand why you should do something, it's much better for the workers to accept such systems. Here it's a system which checks for errors in assembly. It gives you extract of the large action model, or small action model in this case, and then the worker has to do certain actions. Here it should fit in the car door exactly, and there is a physical model behind it with a lot of mathematics behind it, a lot of differential equations have to be solved to find out where you have to, use your tool to fix this error. And this is not only one point, but there are sometimes up to 3-4 points where you have to turn the screw in the right direction. And this is really fantastic because it uses the virtual measurement data analysis which was developed at VW together with the AI system. And it works. We showed it recently to our Minister of Research, and she also liked it very much. We will give a demonstration next week also, I think, for our President of Germany, tomorrow already. So we are in the demo mode. Demo or die is also the new motto of our ministry. But anyway, demos are important. Let me conclude. Some concrete proposals for closer international cooperation. So I think the idea of research and development on distributed, high-precision robotic production and networks of smart factories with long-term autonomy, resilience, and sovereignty. are really sometimes are very important for our cooperation here with Czechia and Germany. The joint development of standards for software and hardware AI components which can be certified automatically, as I said, by edge cloud systems are also, I think, something which can give us a tremendous economic advantage. Then the exchange of excellent PhD students, we already discussed this, in things like we have the Talentic Management Organization and AI Grid. And finally, also the exchange of curated empirical synthetic data for advanced training. Also something which can be concretely done. And my conclusion altogether is that the next wave of innovation in industrial AI as a driver for new economic growth will be based on, first, small language models with more compact and high-quality annotated data, because they have an advantage, at least for industrial AI. Approaches such as the TRM challenge, this core assumption of generative AI, which always was, when you look to the newspaper, it's like an arms race. Bigger is always better. Gigantic AI factories, I believe, if you go to these AI factories in 10 years, it's garbage, yeah? Because they bet on only one operation, namely matrix multiplication. And if you look really at the algorithms, you will find that this is not enough. Yeah, it's good to have it, and so it's not a waste, but it is not enough. So the more specialized hardware. And finally, last remark is attention is necessary for transformers, of course, but it's not sufficient for the next level of industrial AI. And last but not least, furthermore, AI systems should not only be trained on text and images, but also on tables. And we in the manufacturing know measurement series, sequences of actions, and process models. That's the core, and it's not text. Normally, engineers don't write a lot of text about their machines. Anyway, thank you very much for your attention. Thank you.
Thank you so much. Thank you. Thank you. That was a really, really inspiring talk. I think it beautifully connects to what we discussed before lunchtime, that we have to be clever in Europe. We don't have the same amount of money or resources as China or America, but we can be clever. And SLMs is a wonderful term in this tech. You're good at these terms, yes, which I will use going forward as well. It's fantastic. I was also very encouraged by the kind of human and emotional element in all of this, and the sovereignty and resilience that comes out of that. So thank you. Thank you very much.